You know, we're surrounded by it every single day. It's in our homes, our furniture, it's woven into our history. I'm talking about timber. It's one of the oldest building materials humanity has ever used. But behind that familiar grain, there's a whole hidden world of biology and engineering. So let's dive into that incredible journey, from a living tree to a structure that can last for centuries.
Okay, so let's start with a question that seems almost too simple, but it's actually really important. We tend to use the words wood and timber like they're the same thing. But in the world of building and engineering, they mean two very different things. So what is the actual difference?
Well, here's the deal. Wood is just the general catch-all term for the stuff that comes from trees. But timber, now that's wood with a specific destiny. It's wood that's been marked for construction. In fact, the word itself comes from an Old English verb, timbrian, which literally meant to build. So by its very definition, timber is wood meant for building.
To really understand what makes timber so incredibly strong, we have to go right back to the source, the living tree. A tree's whole life is basically a masterclass in structural engineering, and the way it grows dictates everything about the material we eventually get from it.
So trees basically have two ways of growing. Some, like bamboo, are called endogenous. They grow inwards, and their fibers are all mixed up inside. But the trees we use for our buildings, they're exogenous. Just think of them as building themselves from the outside in, adding a brand new layer of strength year after year after year.
And these layers, of course, are the famous annual rings. Each one is like a chapter in that tree's life story. You can see the good years and the bad ones. But more importantly, this layered structure of tightly packed cells is exactly what gives timber its incredible strength along the grain.
Now, obviously, not all timber is created equal. You've got your hardwoods from leafy trees like oak, which are super dense and strong, perfect for something like flooring. And then you have softwoods from conifers like pine, which are lighter and more uniform, making them absolutely ideal for the structural framing of a house. The key thing to remember here is that the names have nothing to do with how hard they actually feel. It's all about the tree's biology and the final structure of the wood.
So, once a tree is felled, you might think the work is done. But really, its journey to becoming usable timber has only just begun. It now has to go through this huge transformation from being a living, waterlogged organism to a stable, reliable building material.
And this, right here, is the single biggest challenge. A piece of freshly cut timber, what we call green timber, can have a moisture content of over 200%. I mean, just let that sink in. That means it can be holding more than twice its own dry weight in pure water. You just can't build anything with that. So the solution is a process called seasoning. And no, we're not talking about adding salt and pepper here. Seasoning is the super controlled process of drying the timber to get all that excess moisture, or sap, out from deep inside the wood cells.
And this is, without a doubt, the most important step. This is what separates a pile of logs from a sturdy home. If you don't do this, the timber will shrink and twist and crack as it dries inside your house, basically destroying the whole structure. Seasoning makes it stronger, lighter, more resistant to rot and bugs, and most importantly, it makes it stable. Now, there are two main ways to get this done. You've got the old school method, which is natural air drying, basically just letting Mother Nature do all the work. And then you've got the modern industrial method, artificial kiln drying, which is way faster and much more precise.
Air drying is simple. It's cheap. You just stack the wood with spaces in between and let the air flow through. But, and it's a big but, it is incredibly slow. We're talking years sometimes. And even then, you can only get the moisture content down to about 20%. Plus, the whole time, it's just sitting out there, vulnerable to the elements.
Kiln drying, on the other hand, is this amazing high-tech process. The timber gets rolled into a giant oven, a kiln. But here's the really clever part. First, they pump in steam. And you're probably thinking, wait a minute, why would you add more water? Well, it's because this heats the wood all the way through without drying out the surface too fast, which would cause it to crack. Then, they slowly lower the humidity, and big fans circulate hot air to pull the moisture out perfectly and efficiently.
But even after it's perfectly seasoned, timber's journey isn't over. It's not invincible. It has natural imperfections, and it's vulnerable to a whole bunch of enemies that can weaken it over time.
The most common defect, one you've definitely seen, is a knot. It's literally the base of an old branch that got swallowed up as the tree grew bigger around it. Now, we might like the way they look, but structurally, a knot interrupts the flow of the wood fibers, and that creates a pretty significant weak point.
Another flaw that happens inside the tree is something called a shake. Now, unlike a surface crack, these run between the annual rings. They actually cause the layers of wood to separate from each other. It's a really serious flaw that can completely compromise the timber's strength.
All right, next up, rot. There are two main types to worry about. Dry rot is actually a specific type of fungus that literally eats the wood, turning it into a brittle powder. It's sneaky because it loves to spread in damp places with no air circulation. Wet rot, on the other hand, is a lot more straightforward. It's just the natural decay that happens when wood gets wet and stays wet for a long time.
And of course, we can't forget about insects. Termites are public enemy number one. They are notorious for eating a structure completely from the inside out, causing catastrophic damage before you ever even see a single sign on the surface.
So, given all these challenges, how in the world do we make timber last? Well, over thousands of years, we've developed some pretty incredible techniques to preserve it. And today, we're still innovating, making wood stronger and more versatile than it's ever been.
We have a whole arsenal of methods. There are ancient techniques like charring the surface to create a natural carbon shield. There's applying tar or even just a good coat of paint to seal it from moisture. And then there are modern methods where we literally force powerful chemical preservatives deep into the wood cells using high pressure.
And this is a brilliant example of modern innovation. Plywood. It's not just wood, it's engineered wood. By gluing these really thin sheets together, but turning the grain of each layer 90 degrees to the one below it, we totally cancel out wood's natural tendency to expand or split. The result? A board that's incredibly strong and stable in every direction.
And this quote really just sums it all up, doesn't it? Timber is not a set it and forget it kind of material. But if we understand it, if we protect it from its enemies and respect its nature, its potential to last is just astounding.
So, when you put it all together, you really see why timber has endured as a building material for so long. It's got this amazing combination of qualities. It's incredibly strong for its weight, it's a great insulator, it's easy to work with, and it's flexible enough to perform really well in earthquake zones. And, of course, when it's managed the right way, it's a truly renewable resource.
Which leaves us with one last big thought. For thousands of years, we've relied on this incredible material. It's strong, it's versatile, and it literally grows on trees. In a world of high-tech composites and carbon-heavy concrete, maybe the most innovative path forward is actually to look back to humanity's original smart material and the powerful secrets that are still waiting for us in the forest.